Two bodies A and B are connected with light threads as shown in the figure. Mass of A is 10 kg and the coefficient of friction between A and horizontal surface is 0.3. Mass of B, so that the system will be in equilibrium, is. In the given arrangement, this surface is given as rough surface. Mass of A block is given as 10 kg. Now it is asked to find mass of B block for the system to be in equilibrium. So to solve this problem, let us suppose this point as P. Let us suppose T1 is the tension in the string connected between the block A and point P. T2 is the tension in the string connected between the point P and block B, and T3 is the tension in the string connected between the point P and this rigid support. Now let us draw free body diagram on block A. Its weight 100 newtons acts vertically downwards. Normal force given by the horizontal floor acts vertically upwards. Tension T1 acts horizontally towards right, and because of this T1 tension, if the block tends to move towards right, there comes a frictional force towards left. So there will be a frictional force acting towards left. Since the system is in equilibrium, this frictional force will be static friction. Now let us draw free body diagram on block B. Its weight MBG acts vertically downwards, and tension T2 acts vertically upwards. Now if we draw free body diagram on point P, tension T1 acts horizontally towards left, tension T2 acts vertically downwards, and tension T3 acts in such a direction that it subtends 60 degrees with the horizontal. Now T3 gets resolved into two components as T3 cos 60 degrees towards right and T3 sin 60 degrees vertically upwards. Since the system is in equilibrium, we can write T2 equal to as mass of B block multiplied by G. Let this be first equation. And from the FBD of A, we can write N equals to as 100 newtons. Also we can write T1 equals to as static friction. So this implies T1 is equal to static friction is written as mu s times of normal reaction. And since mu s is given as 0.3, we can write T1 equal to as 30 Newton. Let this be second equation. Now from the FBD of point P, T1 can be written as T3 cos 60 degrees. So this implies T3 is equal to 60 newtons. Also from the FBD of point P, we can write T3 sin 60 degrees equal to as T2. So this implies 60 times root 3 upon 2 is equal to T2. So this implies T2 is equal to 30 root 3 newtons. Let this be third equation. From 1 and 3 equations we can write mass of B block multiplied by G equal to as 30 root 3. On simplification we get mass of B block equal to as 3 root 3 kg. Therefore, for the system to be in equilibrium, the mass of B block should be equal to 3 root 3 kg. Therefore, the correct option is 2.